Welcome back, students. So in the previous lecture we started trigonometry. Now I told you about various trigonometrical ratios. Now today we'll continue with a few more sums based on those trigonometrical ratios. So the first question for today: if 15 cot A is equal to 8, find sin A and sec A. So they have given the value of cot A and you have to find sin A and sec A. So first of all, you see cot A is equal to 8 upon 15. Okay, cot A is 8 by 15. So you make a triangle, right angle triangle obviously, and say the triangle is ABC, in which angle B is 90 degree. Now they have given cot A is 8 by 15. Now cot is base upon perpendicular. You know, tan theta is perpendicular upon base and cot is reciprocal of tan, so it is base upon perpendicular. That means we can take this as 8A and this as 15A. Then only cot A will be 8 by 15. Now using Pythagoras theorem in triangle ABC, we'll find the third side, that is AC. So using Pythagoras theorem in triangle ABC, AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Means 8A whole square plus 15A whole square is equal to AC square. Now 8A whole square means 64A square and 15A whole square means 225A square is equal to AC square. Now 225 plus 64 is 289 A square is equal to AC square. So AC will be 17A because 289 is the square of 17. That means we have found that the length of AC is 17A. Clear? Now we have to find sin A. So when you find sin A, you know sin A is perpendicular upon hypotenuse. That is 15A upon 17A. A cancels out. So it is 15 upon 17. That is the value of sin A. Once again, you can verify the fact that the value of sin A is less than 1 because 15 by 17 as the numerator is smaller than the denominator, so it has to be less than 1. I told you sin A and cos A, they are always less than 1 or maximum they can be equal to 1. Now the second thing that we have to find is sec A. So sec A is reciprocal of cos A. Cos A will be base upon hypotenuse, so it will be hypotenuse upon base. So it is hypotenuse upon base. Now the hypotenuse is 17A and the base is 8A. So it is 17 upon 8 and that is your answer. Clear? The value of sec A will be 17 upon 8. Now we'll do the next question. The next question is, if cot theta is equal to 7 upon 8, find one plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. Okay, so they are given the value of cot theta, that is 7 upon 8, and you have to find the value of 1 plus sine theta into 1 minus sine theta in the numerator and 1 plus cos theta into 1 minus cos theta in the denominator. So first of all, you make a triangle, say ABC, and right angle at B, and take C is equal to theta. Angle C you can take as theta. Now see, cot theta they have given 7 upon 8. I just told you in the previous question that cot theta means base upon perpendicular, because it is reciprocal of cot, tan, so it is base upon perpendicular. That means this is 7a and this is 8a. 7a upon 8a. Cot theta is 7a upon 7 upon 8 means 7a upon 8a you can say. Now using Pythagoras we will find the length of AC. So using Pythagoras Theorem in triangle ABC, AB square plus BC square is equal to AC square, that is 8a whole square plus 7a whole square is equal to AC square. 64a square plus 49a square is equal to AC square. Now 64 plus 49 will be 113a square is equal to AC square. So AC will be a into under root 113. AC is a into under root 113. A into under root 113. So this is the value of A. We have found this is the value of AC. We have found AC. Now, what is the value of sine theta from this diagram? See, if this is angle theta, this is perpendicular, this is hypotenuse. Sine theta is perpendicular upon hypotenuse. You know that. Perpendicular means 8a and hypotenuse is a under root 113. A cancels out. So it is 8 upon under root 113. That is sine theta. And now find cos theta. Cos theta is base upon hypotenuse. Base upon hypotenuse, base is 7a and the hypotenuse is a under root 113. Again a cancels out. 7 upon under root 113. That is cos theta. Now we have to find the value of 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. Now one plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. So we can directly put the value of sine theta and cos theta here to get our answer. But to make our calculation easier, I am going to apply a formula here. A plus b into a minus b is a square minus b square. You know that. Same formula can be applied in the denominator also. So 1 plus sine theta into 1 minus sine theta is 1 square minus sine theta whole square upon, similarly here, a plus b, a minus b, 1 square minus cos theta whole square. The formula that we have applied here is a plus b into a minus b is equal to a square minus b square. Okay. Now see, 1 square is 1 only. Sin theta whole square, that is 8 upon under root 113 whole square. And 1 square is 1 again, 1 minus cos theta whole square, that is 7 upon under root 113 whole square. Okay. Now you see 1 minus 8 square is 64 upon 113. 1 minus 7 square is 49 upon 113. So in the numerator, take 113 LCM. So it is 113 minus 64. In the denominator also take 113 LCM. So it is 113 minus 49. This 113 is cancelled. Now 113 minus 64 will give you, I think it is 49. 103 minus 64 is 49. And 113 minus 49 is 64. So this is your answer. The answer is 49 upon 64. The answer is 49 upon 64. Clear? Okay. So we will move to the next question. So in the next question, if 3 cot A is equal to 4, verify 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square A. It is given that 3 cot A is equal to 4. Now you have to verify whether that relation is true or false, means whether the left hand side is equal to right hand side or not. So first of all, 3 cot A is equal to 4. So cot A will be equal to 4 by 3. Cot A is equal to 4 by 3. Okay. And now you make a triangle, say ABC, in which angle B is 90 degree. Now I told you that cot A or cot theta is equal to base upon perpendicular. Here it is 4 by 3. That means this is 4A and this is 3A. Now in many questions I have already applied Pythagoras. So you can easily apply Pythagoras in this diagram, in this triangle, and you will get the third side as 5, because 4 square is 16, 3 square is 9. When we add it is 25 and square root of 25 is 5. So AC will be 5. Okay. Now see, if I want sine, means perpendicular upon hypotenuse. Now the perpendicular is 3A, hypotenuse is 5A, A gets cancelled, so it is 3 by 5. Now I want cos A, which is base upon hypotenuse, that is 4A upon 5A. Again A cancels out, so 4 by 5. Now you see the left hand side. The left hand side is 1 minus tan square A upon 1 plus tan square A. Okay. Now see, if cot A is 4 by 3, then tan A will be 3 by 4, because I told you that cot A is reciprocal of tan A. Means tan A is reciprocal of cot A. So in place of tan A you can write 3 by 4. So 1 minus 3 by 4 whole square upon 1 plus 3 by 4 whole square. That is 1 minus 9 by 16 upon 1 plus 9 by 16. So in the numerator you take 16 LCM. So 16 minus 9. In the denominator also you take 16 LCM. 16 plus 9. 16 gets cancelled. 16 minus 9 is 7. And 16 plus 9 is 25. So you see, when I solve the left hand side, I am getting 7 upon 25. Now we will solve the right hand side. The right hand side means cos square A minus sin square A. So cos square A means 4 upon 5 whole square. Sin square A means 3 upon 5 whole square. Because I told you cos square A is nothing but cos A whole square and sin square A is nothing but sin A whole square. Now you see it is 16 upon 25 minus 9 upon 25 and now you take 25 LCM. So in the numerator you will have 16 minus 9, that is 7 upon 25. So you can see we have verified that in this case left hand side is equal to right hand side, because left hand side was 7 upon 25 and right hand side is also 7 upon 25. So left hand side is equal to right hand side. Okay, clear? So next question. In the next question, there is a triangle ABC in which angle B is 90 degree and it is given tan A is equal to 1 upon root 3. It is given that tan A is 1 upon root 3. So we have to find first part sin A cos C plus cos A sin C, and the second part cos A cos C minus sin A sin C. Okay, so we have to find these two things. So first of all, tan A is given 1 by root 3 and you know that tan A or tan theta is perpendicular upon base. So you take this side as A and this side is A root 3. Then only tan A will be perpendicular on base. So it will be 1 upon root 3. Clear? Now using Pythagoras Theorem in triangle ABC, AB square plus BC square is equal to AC square, that is A root 3 whole square plus A square is equal to AC square, 3A square plus A square is equal to AC square, 4A square is equal to AC square, then AC will be equal to 2A. Clear? Because square root of 4 is 2, so AC is 2A. This side is nothing but 2A. Now, first of all, to find the value of these two parts, we need sin A, we need cos A, we need sin C, we need cos C. So, first of all, sin A, that is perpendicular upon base, perpendicular upon hypotenuse. If I am finding sin A, means A is the reference angle, then perpendicular is BC, hypotenuse is AC. So A by 2A. So I have found sin A. Now cos A. Base upon hypotenuse. Base is AB. Hypotenuse is AC. A root 3 upon 2A. So it is root 3 by 2. Cos A is root 3 by 2. Then I am going to find sin C. So sin C remains perpendicular upon hypotenuse, but now when I am talking about sin C, means C is the reference angle. So AB becomes perpendicular and AC remains the hypotenuse. So it is AB upon AC. That is A root 3 upon 2A, that is root 3 by 2. Okay, and now I want cos C, which is base upon hypotenuse. But now as C is the reference angle, the base will be BC. So BC upon AC. That is A upon 2A. A can be cancelled, 1 upon 2. So I have found that value of cos A is 1 upon 2. Now we have found all the values. So we can put them and get the answer of these two parts. The first part, sin A into cos C plus cos A into sin C. So sin A is 1 upon 2. Cos C is again 1 upon 2. Cos A root 3 by 2. Sin C is root 3 by 2. Now see, 1 into 1 will be 1, upon 2 into 2 will be 4, plus root 3 into root 3 will be 3, upon 2 into 2 is 4. So if you take 4 LCM, it is 1 plus 3. So 4 by 4, that is equal to 1. So the answer to the first part is 1. Answer to the first part is 1. Now the second part, cos A cos C minus sin A sin C. Cos A cos C minus sin A sin C. Once again you see, cos A is nothing but root 3 by 2. Cos C is 1 upon 2. Sin A is 1 upon 2. Sin C is root 3 upon 2. That means root 3 by 4 minus root 3 by 4, and that is nothing but 0. So the answer to the second part is 0. Answer to the first part is 1 and answer to the second part is 0. Clear? So we will move on to the next question. The next question, there is a triangle PQR in which Q is 90 degree. PQR is a triangle in which angle Q is 90 degrees. Now they have given the length of PQ is 5 centimeters. It is given that PQ is equal to 5 centimeters. And it is given that PR plus QR is equal to 25 centimeter. PR plus QR 25 centimeter. Now find first part sin P, second part cos P, third part tan P. So you have to find the value of sin P, cos P and tan P. Clear? So using Pythagoras in triangle PQR, PQ square plus QR square is equal to PR square, means 5 square plus, now in place of QR we can write 25 minus PR. 25 minus PR. You see, from the condition given, QR is equal to 25 minus PR. So in place of QR, I have written 25 minus PR and square is there, is equal to PR. Okay? 5 square is 25 plus. Here I will apply the formula A minus B whole square. All of you know that A minus B whole square is A square minus 2AB plus B square. So it is 25 square minus 2 into 25 into PR plus PR square is equal to PR. So PR square can be cancelled. 25 plus 25 square is 625 minus 50 PR is equal to 0. 650 is equal to 50 PR that gives you PR is equal to 13 centimeter. 650 upon 50 will be 13. So PR is 13 centimeter. We have found PR as 13 centimeter. And now if you put PR is equal to 13 centimeter here, QR will be 25 minus 13, that is 12 centimeter. QR is equal to 25 minus 13, that is 12 centimeter. Okay. So once we get all the formula that we have applied here is a minus b whole square is equal to a square minus 2ab plus b square. That is the formula we have used here. Clear? Now, when we know all the three sides of the triangle, it's very easy to write down the values of sin p, cos p and tan p, because the sin p is perpendicular upon hypotenuse, and perpendicular upon hypotenuse means 12 upon 13. Similarly, cos p is base upon hypotenuse, and base upon hypotenuse means 5 by 13. And tan p is equal to perpendicular upon base, that is 12 upon 5. So this is answer to all the three parts. Sin p is 12 by 13, cos p is 5 by 13, and tan p is 12 by 5. Okay. Now trigonometrical ratios of few spatial angles. Trigonometrical ratios of few spatial angles. Now, all of you pay attention. I have a triangle ABC which is right angled at B, and AB and BC are equal. Means it is right angled isosceles triangle. This triangle is right angled isosceles triangle. Angle B is 90 and AB and BC are equal. Now you know the sum of all the three angles of a triangle is 180 by the angle sum property of triangles. If one angle is 90, that means the sum of remaining two angles should be 90. And as these two sides are equal, and you know that base angles of an isosceles triangle are equal, that means these two angles are equal. That gives you this angle will be 45 degree and that angle is also 45 degree. Clear? One more thing. Suppose the length of this side is small and this is also small. Now using Pythagoras theorem, we are going to find the value of the hypotenuse, that is AC. Using Pythagoras theorem, in triangle ABC. AB square plus BC square is equal to AC square, that is A square plus A square is equal to AC square. 2A square is equal to AC square, so AC will be A root 2. So we have found that length of AC is A root 2. The length of AC is A root 2. Now suppose this angle 45 is the angle of reference, then sine 45. I told you in a right angle triangle, for the angle of reference, sine theta is perpendicular upon hypotenuse, means AB upon AC. AB upon AC. Now AB is small a and AC is A root 2. A can be cancelled, so it is 1 upon root 2. So you can see the value of sine 45 is always 1 upon root 2. So 45 is a special angle and sine 45 is 1 upon root 2. Now cos 45. Cos 45, once again it is base upon hypotenuse, means BC upon AC, that is A upon A root 2. Once again A cancels out, so it is 1 upon root 2. So you can see the value of cos 45 is also 1 upon root 2. Now tan 45. Tan 45, it is perpendicular upon base, so AB upon BC, that is A upon A, that is 1. So you can see we have found that sine 45 is 1 upon root 2, cos 45 is 1 upon root 2 and tan 45 is 1. If you take the reciprocal of these values, means the reciprocal of sine 45 will give you cosec 45, reciprocal of cos 45 will give you sec 45, and reciprocal of tan 45 will give you cot 45. Clear? Okay, now we will find the value of few more special angles. This is an equilateral triangle, say ABC, and we assume that each side of the triangle is of length 2a. Why 2a? Why not a? Because it makes our calculation easy. You will see 2a. I have taken all the sides as 2a. All of you know that in an equilateral triangle all the angles are equal to 60 degree. That means this angle is 60 degree, this angle is also 60 degree, and this angle is also 60 degree. Now what you do, from A you drop a perpendicular on BC. Let this point be D. Okay? Now you know in an equilateral triangle when we drop a perpendicular from the vertex on the base, it bisects the base. Means this side is small a and this is also small a. Clear? And it bisects the vertex angle also. That means this angle is 30 degree and this angle is also 30 degree. Okay? Now say in triangle ABD, as ABD is a right angle triangle, Pythagoras theorem can be applied. So one side is 2a and the one side is a. So we will find the third side AD using Pythagoras theorem. So using Pythagoras theorem in triangle A B D, AD square plus BD square is equal to AB square. That is AD square plus A square is equal to 2A whole square. AD square plus A square is equal to 4A square. So AD square is equal to 3A square. So AD will be A root 3. So we have found that length of AD is A root 3. Okay. Now you see, in triangle ABD, if I take 60 as the reference angle, then sine 60, that is perpendicular upon hypotenuse, AD upon AB, means A root 3 upon 2A, that is root 3 by 2. So you can see we have found that sine 60 is root 3 by 2. Now cos 60, that is base upon hypotenuse, so BD upon AB. Now BD is small a and AB is 2a, so it is 1 upon 2. Cos 60 is 1 upon 2. And then tan 60, perpendicular upon base, AD upon BD. AD upon BD. AD is A root 3 and BD is A, so the value is root 3 only. So you can see I have found sine 60, cos 60 and tan 60. Values of sine 60, cos 60 and tan 60. Now from the same triangle, if I take 30 as the reference angle, then sine 30. I told you if 30 is the reference angle, then BD will become the perpendicular and AD will become the base. So it is perpendicular upon hypotenuse means BD upon AB. BD is A, AB is 2A, that is 1 upon 2. Then cos 30. Cos 30 is base upon hypotenuse, that is AD upon AB. Now AD is A root 3 and AB is 2A, that is root 3 by 2. And then tan 30. Tan 30 is perpendicular upon base, that is BD upon AD. BD is A, AD is A root 3, AA cancels out, 1 by root 3. So we have found the value of sine 30, cos 30 and tan 30. Clear? In this way we can find these values. But there is a table and you have to learn the table, because time to time we have to use those values. So I will give you the table over here. Sine, cos, tan. The special angles are 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Actually, they can be extended to 120 degree, 135 degree and 150 degree also, and so on. But that is in the higher classes. In class 10th, you have to you must know these values only. Now sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Clear? Excuse me. Cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 upon 2 and cos 90 is 0. Clear? Then tan. Tan 0 is 0, tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3 and tan 90 is infinite or undefined. Clear? So if you see these values and check from this table, you will see their values are the same. Now there is only one option for you. You have to learn. You have to learn these values so that we can apply them in various questions. Although I will tell you a trick in case you forget these values, you can write the values 0, 30, 45, 60 and 90. Sine. I am going to tell you sine values. You start from here 0, 1, 2, 3, 4. In order you write 0, 1, 2, 3, 4. And then divide all the numbers by 4. Divide all the numbers by 4. And then put the square root on all the numbers. Like this. Now 0 upon anything is 0 and square root of 0 is 0. So here you will get 0 only. Square root of 1 is 1, square root of 4 is 2, so it is 1 upon 2. Now if you cancel it, square root of 1 is 1 and upon root 2. It is root 3 by 2, you can see, because square root of 4 will be 2. 4 upon 4 is 1, square root of 1 is 1. So like this, you see, same. And then for cos, you just write the series in reverse order, starting from there. 1 root 3 by 2, 1 upon root 2, 1 upon 2 and 0 in reverse order. And in the previous class I told you that tan theta is sin theta upon cos theta. Means if I divide sin upon cos, I will get tan. 0 upon 1, 0 upon anything is 0. This upon this 2 gets cancelled, 1 by root 3. 1 by root 2 upon 1 by root 2 will be 1. When this root 3 by 2 divided by 1 by 2, 2 gets cancelled, it is root 3. And anything upon 0 is infinite or undefined. That is the last. Clear? So you must remember all these values. Now there is a question. A triangle is given ABC, which is right angled at B. This angle is given 30 degree and this is given 5 centimeter, and the question says find BC and AC. Find BC and AC. So first of all, you see in this triangle the perpendicular is given. So sin theta is perpendicular upon hypotenuse. So if I take sin C or sin C, okay, sin C, this is the reference angle, so this is perpendicular. AB upon hypotenuse is AC. Now sin C means sin 30 is equal to AB is given 5 and AC we have to find. Now the value of sin 30, just I told you sin 30 is 1 upon 2. So sin 30 is 1 upon 2 is equal to 5 upon AC. If you cross multiply, AC will be what? 10 centimeter. So AC is 10 centimeter. So we have found AC is 10 centimeter. Okay. Now to find BC, the base, we can apply tan or we can apply Pythagoras also. So if I take tan C is equal to AB upon BC, because tan C is perpendicular upon base. Now that is tan 30 is equal to 5 upon BC. You know tan 30 is 1 upon root 3, I told you, is equal to 5 upon BC. If you cross multiply, BC is equal to 5 root 3 centimeter. Okay, that is your answer. So now I have found all the values. Clear? I'll do one more question. Evaluate 2 cos square 60 plus 4 sec square 30 minus tan square 45 upon sin square 30 plus cos square 30. So we have to find the value of these quantities. Now see, 2 into, I told you the value of cos 60 is 1 upon 2. You can check in the table, cos 60 is 1 upon 2. Then that is sec 30. You know sec 30 is reciprocal of cos 30. Cos 30 is root 3 by 2. Then sec 30 will be 2 by root 3. So in place of sec 30 you write down 2 by root 3 because it is reciprocal of cos 30. You can check in the table, the value of cos 30 is root 3 by 2. So the value of sec 30 will be 2 by root 3. Minus tan 45, you know it is 1 square. Upon sin 30 is 1 upon 2. So 1 upon 2 square. Cos 30 is root 3 by 2. So it is root 3 by 2 square. Now 2 into 1 upon 4 plus 4 into 4 by 3 when you square minus 1 upon 1 by 4 plus 3 by 4. Now see, 1 by 2 plus 16 by 3 minus 1 upon, here you take 4 LCM, so it is 1 plus 3. So in the numerator you take 6 LCM, 3, 32, 6, and here it is 4 upon 4. Okay. Now 32 plus 3 is 35. 35 minus 6 is 29. So 29 by 6, because 4 upon 4 is 1. So it is, the answer will be 29 by 6. The answer is 29 by 6. So this finishes the topic, that is value of few spatial angles, trigonometrical ratios of few spatial angles. So we'll continue with the topic in the next class also. We'll do few more examples and do the sums given in the assignment.